get started though. So for the ones that have, so we're all excited that you're here. I'll let you introduce yourself. I'm Kaylee. I'm the community marketing manager at TigerGraph, and we're also glad that you decided to join us today on our final TigerGraph Thursday event.
All right, thank you, Kali. And my name is Jay Yu. I'm the new VP of Product Innovation at TigerGraph. I just joined the company last Monday, so this is my 8th day. It's pretty exciting to be in this fast-moving, innovative company.
Yes, yeah, we're so excited. He just joined and he came from Intuit. But before we discuss a little bit of that, we want to hear more about your background, because these students here, are probably sitting in the same spot. Well, they hope to sit in the same spot probably as where you are today. So can you tell us more about where you went to school, what your major was, and what led you into a position that you could be the VP of innovation at a company like TigerGraph?
Awesome. Thanks for the question. We could spend all day here if you want to know everything about me, but let me be brief. I was born in Shanghai, China. I came to the States when I was right before I turned 20. I actually transferred from a Chinese university, one of the top engineering school there, Shanghai Jiao Tong University, to University of Wisconsin-Madison to study computer science. That was back in 1988. So I'm an old man. But it's such a great experience. One of the reasons I want to come to US to study computer science is it is absolutely the best place, the most innovative place. A lot of things about computer science, programming, a lot of startups is all define what this industry is about. So basically I was like a sponge. I was trying to learn as much as possible, all the programming language, operating systems. And then I also University of Wisconsin-Madison back then was very known for its systems research. One of the areas is database systems. So I fell in love with that. And by actually taking some advanced class, I was talking to the professor. They basically say, hey, this is one of the top 3 programs in the world. Do you want to stay to pursue your even more advanced postgraduate education? That's how I decided to stay. I didn't know I spent a lot more years in school after undergrad, and then I finally got a Ph.D. from University of Wisconsin-Madison, focused on database systems research. That was a very rewarding experience. So anyhow, that's my background in terms from an education point of view.
Yes, and we know that you have a few patents. Can you talk about those? Many patents.
Yeah, so this is actually more leading to after I got my PhD, even while PhD, one of the key things about doing research in the database system is really about innovation. Innovation is something, even though you may sound like it's hard, no, it is about finding something, doing something different, make it impossible possible. There's always to do it. So it's really about problem solving. It's about you open your mind, not be constrained by what you have today, always have a really daring goal, say, hey, we can do much better, faster, cheaper. And as long as focus on that, you will figure out creative solutions, and those creative solutions itself just innovation. So I'm fortunate enough, after getting the education, I joined a bunch of companies. I did 3 startups before I joined Intuit, which is one of the biggest brand name, TurboTax. Hopefully you guys probably don't pay tax right now. The minute you do, please use TurboTax. And then have Quicken, have Credit Karma, have small business accounting. And in those space, I start innovating, say, how do we solve customers' problem using technology? And there's a lot of opportunities. So I have about 28 patents ranging from database systems to consumer financial apps. And one of the patents for them will give you a taste of what that innovation looked like, because back in 2005, I'm actually based in San Diego. So UCSD students, I'm local. I love to meet you guys. I like to stop by. But back in 2005, I actually hired one of the interns, one of the master students. And working with me, back then, we have some curiosity. So innovation usually is driven by curiosity, right? We're curious about what is the state of art in natural language processing. That was 2005, 15, 16 years ago. How can we use it to automate a lot of the mundane work we're doing today, right? Or even back then. So what we did is spend one summer, 3 months. We were able to leverage state-of-art NLP technology from Stanford. There's a statistical parser basically doing natural language processing, parsing. We're able to turn English instructions from IRS, which is think about those are requirements for tax laws, right? We process that will automatically turn into running code. So that was an example of what innovation is really about. Initially, nobody believed it was even possible, but we said, let's try. Let's see what's possible, right? Even though we did not completely solve the thing, we at least say, hey, for simple form, for this kind of a problem, we are able to solve it. So that leads to one of the patterns there. So I'm just using that example. Innovation is all about thinking differently, just like what Steve Jobs does with iPhone. Nobody thought even that thing could exist. But guess what? You have the audacity, you have the ability to dream, then everything's possible. As long as you have the passion, the drive, as well as the strong problem solving skills, you should be able to get it.
No, thank you so much for that. I'm sure some of these students here will eventually create a few patents. And so just the kind of journey that you had, that gives them some kind of insight when they get a great idea and they go through a new use case and they're able to develop technology, definitely get it patented. So back to, Intuit. So when you were at Intuit, you were using TigerGraph. Can you tell us a little bit more about, your experience getting, how did TigerGraph even become on your radar? How did you even think that you were needing to solve graph related problems? Can you tell us more about that?
Yeah, that's awesome. So at Intuit, I actually been there for 18 and a half years, almost 19 years. It's a long journey. I witnessed how the company grows over time by using technology. So one of the key things about Intuit is we are a consumer app. By the way, we have more than 100 million consumers using our consumer-faced financial apps like TurboTax, Mint, and also Credit Karma. We also have 6 million small businesses using our software to manage day-to-day their business process, operation, accounting, and so on. So payment, payroll, even applying for a loan. So we have a lot of data. Unfortunately, as big company always facing this challenge called data silo. Data silo about each application have its own data, defined its own way because there's different teams developing that. So pretty much from an enterprise point of view, when you look at those data, even though those data sometimes contains the same information can be linked, they're not. So that actually, without that kind of ability to glue things together, missing a lot of opportunity to understand how customers are using our product, whether there's cross-sell opportunities, whether there's any way to improve their thing, understand the customer better. So this is something sometimes we call the customer 360. In the meantime, there's also another challenge called fraud detection. The fraud detection is really about, because as any successful company, financial company, there's a lot of fraudsters out there. Try to pretend to be somebody they're not, try to steal money from small business or from your personal account. So the way to fight fraud is you have to have a lot of data and see their relationship. And that's where graph comes into place. Before TigerGraph, the team at Intuit I was leading identified that kind of problem is best solved for graph. So what is a graph problem? Graph problem is very different than traditional relational database. Relational database turn everything. I don't know how much database background you have because I have a PhD. So let me actually do an intro. So how you build database? You first start with something called, you have to draw a design called ER diagram, entity relationship diagram. You say there's a notion of a person is related to another person. The person has attributes, name, age, blah, 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 right? So for example, Jay is an instance of person, Carly is another instance of person. We're related because we work for the same company. So start with a very clean conceptual definition, very natural. But then relational database then say, hey, in order to make it working efficiently, I need to map to a physical schema on the relational database. So we turn this notion called a person into a table. And table have columns, right? So if there's a person table, there's columns. But then how do you capture the relationship? You cannot use column to, so then we invented this thing called foreign key or joins. We have to write queries, say, hey, find a person with name J. And then there's a column called colleagues, right? And that colleagues is actually basically a reference to another table. Oh, basically, actually, is Jay works for company TigerGraph. Then we want to join, say, find everybody all work for TigerGraph, and then this is Jay, this column. Now you can do it. It's very efficient, but then you lose the original cleanness of, oh, I have a graph. There is a node called person relate to another person. There's a relationship called working relationship. That's what graph really shines. Instead of try to have to translate from a very clean logical schema to a physical schema to fit into a relational world, have SQLs, query drawings, graph literally say, whatever you represent at the logical level, we help you to do the same thing in the physical, meaning how we store data, how we process data, just follow the natural way. So we identify fraud is the best use case for that. Why? Because in order to detect fraud, fraudster is very smart, right? They actually try to do something. Once they get detected, they try to hide themselves, create another entity, automatically generate a lot of different entities. But no matter what they do, there will be traces to link them together. And this is where graph comes in play. I can see this particular person, a fraudster, they use the same device as another person. Then the other person, very likely, is also a fraudster, right? And then that fraudster has some transaction relationship. If the transaction is suspicious, that means they'll create artificial entities to trade with each other. So with this graph, with this connectedness, then we can detect likely these group of people or user or company likely is a result of fraud. So that's actually clear. So the team at Intuit identify that's natural problem. So then the next question is, which technology do we use? So we went through a whole benchmark. In business, you always say you don't believe marketing, by the way. It's not about somebody put a slide, that's cool, let's use it. Let's actually put it into test. So this is how we discovered TigerGraph, right? We put TigerGraph, we put Neo4j, we put Neptune. All vendors say, hey, we have this use case. We have this terabytes of data. Why don't we put through each system to see which system performed the best? TigerGraph was the clear winner 3 years ago. And that's how Intuit picked TigerGraph. So anyhow, that's a story how we actually, long story, how we actually lead to TigerGraph.
No, well, first of all, thank you. We're so excited that you did use it 3 years ago to bring you here. We're just ecstatic to see what's going to happen in the future. But to kind of touch base on maybe more practical applications for the students in their courses, where could you see them using graph? Because from what we've discovered, a lot of students haven't had experience with graph in college, and what types of problems could they solve that they may not be aware of?
Yeah. Great question. The graph is so new. That's why it's not integrated with any curriculum yet.
Innovation. They can be.
It's new innovation, but I can tell you that's why if you want to be on the trajectory to future, you absolutely have to learn graph. And I give you a bold prediction: in 5 to 10 years, graph will replace relational database. Right. So in the meantime, what do? It's very simple. First of all, I do recommend you take database classes because the foundation about data is important for you to understand the current technology, how that works, how it is used to solve for big data problem. Those are the foundational things. No matter how it's implemented, whether it's relational or not, you need to have a pretty good understanding. Then I will highly recommend you just go to TigerGraph. We have wonderful tooling. It's all free. It's all cloud-based. You just register. We'll spin up an instance in the cloud. You can start playing. Given that one of the first things you can easily do is whatever the example in your relational database class, you say, I'm going to try that to do the graph way. That will give you immediately do side-by-side comparison. You actually get to appreciate why the graph way is much simpler, much straightforward, much easier to help people, a human being, process information. And also it's much fun to play with because you get instant visualization of how data is related to each other. Okay. And then the other area, I don't have the actual link. We can share that link. We have a lot of interns coming to us and also our partners, basically our customers. And then we give them open challenges. And those interns are very creative. literally anything in the world can be modeled as a graph, right? I see people come in and say, hey, I want a graph to solve for employee relationship management. Of course, the easiest graph you can always replicate is your social graph, your professional graph. And Google has this knowledge graph. So you can easily try to replicate them to see how that works. But there's many other areas. Any problem you can think of, there's always a graph behind it. Graph is being used to do drug discovery, customer 360, link all these things together. Even your class, even the knowledge about what classes, how they depend on each other itself is a graph. So again, you'll have a lot of fun playing with. We have the right tool. We have the most easy to use tool for you and for you to play, to learn. And once you got that, believe me, this is the skill of the future.
No,
and you want to be on the forefront instead of lacking behind.
So now that you've inspired them all to get into Graph, I know what they'll be thinking next is how do we get a job either at TigerGraph or, at least one of our customers. We want to recommend, the students have done a great job. They've gone through a 3-series certification with quizzes.
Yes.
And you have a great experience. You've been in leadership. What do you look for and what do you recommend that they can do to set them up for success, to differentiate themselves from other data science, computer science students?
That's
what
awesome.
qualities?
That's a great question. So this actually, as I said, it's the future. That means there's growth. Gartner report mentioned in the next I think 2 to 3 years, basically, they already know that 70% of the big enterprises, when they talk about AI, they mention graph. Now, a lot of them are not ready yet. They're looking at it, they're evaluating it, but a lot of them are already moving ahead. That's why TigerGraph, we're seeing great growth. In terms of, we have a huge customer pipeline. Each of those customers, when they take on the graph project, one of the first challenges is, where do I get expertise? Because most people just know how to do SQL. There's so many people knows how to do SQL relational one. Try to hire somebody with graph is very hard for them. And that's actually one of the barriers for them to adopt graph. Even a lot of people have the intention to. So I don't think you'll have any trouble. So there's a couple of things. So number one, TigerGraph is growing. We grow from 90 people a year ago. Now it's 210. And we like to easily add 100 people. By the way, I'm opening a San Diego Innovation Lab. And our CEO want me to hire 100 people.
Wait, let that sink in. Let's let that sink in. What did you just say? There's going to be no shortage of jobs if you learn graph.
No shortage of jobs.
You want to hire 100 people in San Diego.
Yes, all levels, experience, not experience, all kinds of functions. And in addition, make it even sweeter. I think I want you guys to also, I'm also looking for a year-round internship. While you are taking classes, you have some spare time, you want to earn some, of course, pretty decent money, right? As you know, our internship paid really well while learning and applying the knowledge you have through the certification process. Please talk to me. And we have a lot of opportunities. And one of the reasons for this innovation lab created in San Diego, first of all, I'm based in San Diego. I don't want to move anywhere else. This is one of the best places in the world to live. And sorry, anybody else not living here. A second of all is to be close with UCSD. We know there's a lot of talent, a lot of talented students, undergrad, grad. Also, our chief scientist, our chief technologist is Professor Arlene Josh. I think he teaches some database classes. He actually invented some of the coolest query language features for TigerGraph. So I like to collaborate with him, with his students, graduate students, undergrad students, as well as all of you who are interested. There's a lot more innovation we can do to making sure our technology keep evolving to support the rapid growth of the graph industry.
No, thank you for that. And you touched on a really good point about the GSQL that your Professor Lean. So you all, if you take his class, you can talk to him about how you got to be on this webinar and you got to meet Jay, but kind of tell us more about GSQL and why is that so important for students to learn and just in general, the workforce compared to SQL?
So one of the first things I talk about graph is a natural representation of data relationship. So you want to actually put data into this representation, but then what do you do with the data? And the query language like a GSQL is a way for you to query the data, to discover insight, to run graph algorithms, right? And that's really the key. So you can think about GSQL is equivalent to SQL to relational database. Without SQL, you cannot do much with the database. So that's what GSQL. One of the coolest thing about GSQL is it's trying its best to mimic what SQL is about. So we'll reduce your, if you, as I say, if you take a database class, understand how relational database work, you already have the foundation. You'll find our GSQL query syntax are very similar, with a little bit tweaking about, a focus on graph traversal and graph algorithm. So that's absolutely a must if you want to actually unlock the potential or power of graph, because our job is to demonstrate, not only convince people to move data to this shape, but also to demonstrate all the great things you can do with this data. And GSQL is absolutely the most important tool for that.
No, thank you so much. And one of the things too that we found, if you're not familiar, is we have a great developer community where you can join our Discord chat, and we'll give great info. We're really helpful at kind of helping you along that way. So if you get into any challenges, if you want to create some fascinating machine learning algorithms, we have a whole team that can help you along those to do that. And I know we have a few minutes left. So is there anything else I didn't cover, Jay, before I open this up for some Q&A?
Yeah, very quickly, I think you mentioned, I didn't emphasize this, while we turn things into a graph, itself is already have AI built in. When you turn into a graph, you're running graph algorithm, you're already doing machine learning without knowing about it, without actually all the pain of preparing data, label data, because graph naturally already captured the human knowledge, is already AI. But what's more is we can have a layer of integration with machine learning. So that's why what Holly said is absolutely right. That when you actually interested in AI, graph is the foundation for AI. So that's the last point I want to make.
No, thank you. And that, we'll be making some exciting announcements coming up. But what we'd like to do is, do some hackathons with the University of San Diego. So some of those topics will be some of the challenges that we have. But enough about that. So now I want to open it for a Q&A session. I know whenever I do webinars, I don't like asking questions. So I'll kind of pause here. Does anybody have any questions? And then if not, I'll just follow up with a few more final ones. I want to add that some of the people that are here, they all passed their 3 quizzes. So they're going to get to be featured on our website for the certification.
Oh, wow. Please talk to me. I want you in my lab.
You have a great opportunity. He's probably knows more than most people that we're lucky that we have him, is what I'm trying to say. So
that's awesome. I know it's a shy group. Usually, people are not shy, I understand, but we have a lot of opportunities. So please reach out to me. You can find me in LinkedIn, or you can actually release my email. So please, I love to work with people with passion, with energy, want to learn. Don't worry, you feel like you're still new, or we'll help you. But this here. Oh, there's a question, by the way.
Oh, good. Let's see.
Should I stop using SQL and start moving all data to graph database? So depending on what you're doing. If you're doing homework assignment, don't do that. You're not gonna. So I think still important to understand, to know how SQL works. But in addition, I'll first recommend doing a graph version of that for your own benefit, to compare contrast. Once you feel comfortable, I truly believe you can ditch relational. But before you ditch, making sure you understand both, and then you do your own comparison. And I can provide help in terms of if you have any questions. That's a great question, by the way, Luis.
Do we have any others? And if not, what types of other things do you think that maybe go on like overlooked, because maybe people aren't as familiar with graph, so they may not know, what do the students not know that they don't know is what I'm trying to say.
This is hard. I would say, again, go to our website, go to the community page. That's where you get the best help. 3-4 years ago, graph was not there. I did not pay too much attention. How I pay attention, I started reading blogs, right? And one of the person I highly recommend, Dan McCurry. He's one of the most, I would say, the most decorated, most experienced, and also most thoughtful technical person. He's a distinguished engineer in Optimum. He's the pioneer. His blogs, I really enjoy reading. So I highly recommend you follow his blogs on Medium and so on and so forth. That's the best way for you to learn from the best. And I have a few linking posts, sometimes recommend stuff. You guys can take a look at it, but our website, TigerGraph.com, and the community has a lot of interesting materials, videos, tutorials for you to understand. So anyhow, that's a rich set of resources for you to leverage.
Well, thanks. And then one other thing too, that you can do with Graph that we recently found out with one of our student ambassadors at UC San Diego is how you can bring rich data sets in from different industries. So you can bring data sets in from the ocean data sets that you guys have at Scripps all the way to weather data to location data, and then you can use TigerGraph to solve the challenges. So as we kind of progress through our series and once we release some more things that we're doing, you'll get the chance to experiment with all of that. So with that, if there aren't any other questions, I want to thank you.
I'd like to add on that. That's awesome. What I forgot to add, graph is fundamental. Anything, scientific community, business community, finance, there's a graph problem anyway. Any problem can be mapped to graph. So if you have opportunity working with professor on other problems, Scripps Institute, whatever, you can also think about that. Again, I'm available. Please reach out, say, how can I use graph to solve this problem? I'd love to help you on that.
Great, and thank you. And we have great, yeah, definitely follow up and we'll be in touch. Reach out anytime. We are designing some hackathons for you guys to compete against UC San Diego students as well as other students across the country, as well as some other initiatives that we're doing. So we appreciate you. Thank you, Jay, so much for your time. Yeah. Hopefully this has inspired you all to get into Graph and to use it in your next career. And remember,
there's a question. We're out of time. Could you actually send me an email? I'll type my email in the, can I type in chat? Maybe, yeah. Right, send me an email, I'll follow up. Again, I love those questions. So the question that Apache Spark is a very good one. Let's discuss that. It's probably a little bit more complicated than a simple answer. But again, I would love to keep this thing open and offline, take it offline. Thank you so much for this.
Yeah, thank you all so much. We'll create a blog about your question and then Jay's response. So thanks again, everyone. And the winner for the $100 raffle is T. So I will follow up with her and I will reward her. Thank you all so much. And there's many other opportunities to win swag and money. So we'll keep that updated. So have a great rest of your day. And thanks again for joining this series.
Goodbye.
Bye.